Hi, welcome to this lesson on analytical geometry, tangents to circles, part 2. Let's have a look at question 1. m, -2, -5 is a point on the circle given by the equation x squared plus y squared plus 18y plus 61 equals 0. Determine the equation of the tangent at m. Okay, so first of all, we need the center of the circle. And to do that, we're going to have to complete the square on these terms here. So y squared plus 18y. And what I'm going to do is I'm going to move 61 over and make it -61. So I just need to complete the square on y, because x is already completed. I can write it as x minus 0 all squared. Okay, so how do I complete the square here? Half of positive 18 is positive 9. And then if you square 9, it is 81. So I need to add 81 and then immediately subtract 81 to balance the equation on the left. That equals -61 on the right. So I have x minus 0 all squared plus, this will factorize nicely into y plus 9 all squared, right? Because we had y squared plus 18y plus 81 in this trinomial. And then I'm going to move this 81 to the right-hand side, so it's going to become positive 20 on the right-hand side. So there is your circle with center C. The coordinate is given by 0, -9. And your radius is root 20, okay, which is 5 times 4, so it's 2 root 5 units. Okay, so we've got all the information about the circle. So now 0, -9 is over here. And we know there's a point -2, -5 over here, which is m, -2, -5. So the circle looks something like this, roughly. Okay, so the question asked us to find the equation of the tangent at m. So here's the point m. Okay, so not the most accurately drawn, but what can we speculate from this rough diagram geometrically? Well, first of all, I can speculate the gradient is going to be positive, and it looks like the value for c is going to be negative based on the rough diagram that we drew. Okay, so let's just see if that's correct. So what are we going to do? First of all, we need the gradients of the radius line. So from -2 to 0, it's 2 units across. And from -5 to -9, that's 4 units down. And again, you can see the gradient's negative by the slant of the line. So the gradient's going to be -4 over 2, which is -2. So therefore, the gradient of the tangent line is going to be the negative reciprocal, so it's going to be a half. Because if you multiply those two, you get -1. So therefore, so far the equation of the tangent line is y equals a half x plus c. So the gradient is a half, which is positive. So that checks off that geometrical interpretation we looked at earlier. Then, to find the point c, I substitute the point of contact, m, which is -2, -5. So y is -5, x is -2 plus c. So I have -5 equals, -2 times a half is -1 plus c. So if I add 1 to both sides, I get c equals -4. Okay, and that's pretty close to what we had. So c is a negative value. That makes sense based on our geometry. So y is equal to a half x minus 4. That is the equation of the straight line tangents at the point M to this specific circle. Awesome. I'll see you in the next one.